Hello students, welcome to the class. In today's class, I will continue from the last lecture. In the last lecture, I solved 5 numericals. Today, I will solve 5 more numericals. Okay? So, the question number 6 is, a large non-conducting sheet S is given a uniform charge density and two uncharged small metal rods A and B are placed near the sheet S as shown in the figure. Then you have to choose out of these 4 options which one is correct. Okay, let me explain. See, the sheet S is given a uniform charge density and it could be a positive charge or negative charge. Okay, let us consider the charge uniform charge density given to that S is positive. Okay, let's say it's positive, then it will have positive charge on it. Then you studied induction method. So by the method of induction, then what will happen? The metal rod A will have negative charge, will acquire negative charge in that end and positive charge at this end. Okay, and due to that induction, the metal rod B will now have negative charge in this end and positive charge at this end, right? Then of course the sheet S will attract A because this is positive charge and negative charge, positive negative will attract, and S will also attract B because this end has positive charge and this end has negative charge. So S will attract both A and B, and A will also attract B because the at that end A has positive charge and at this end B has negative charge. So positive and negative will attract. So A and B will also attract each other. Means A of A is correct, B is correct, C is correct. Means all of these are correct. Means option D is a correct option. Okay. Okay. Let's move to the next question. Okay. The question number 7 is, three charges minus Q1 plus Q2 minus Q3 are placed as shown in this figure. Then you have to find the x component of the force on this Q1 is proportional to either option A, C, B, D. Out of this 4 option, one is correct. So you have to find which one is correct. Okay. So let us find which is the correct option. Okay. First of all, on the charge minus Q1, the force due to Q2 will be nothing but, let's say F on 1 due to 2 is nothing but 1 by 4 pi epsilon naught Q1 Q2 by R square. And what will be the direction? The direction will be along positive x-axis, right? Along positive direction of x-axis. Along positive direction of x-axis, right? Because Q2 will attract Q1 along this direction. Okay. What will be the force on 1 due to 3 due to Q3? It will be nothing but 1 by 4 pi epsilon naught Q1 Q3 divided by R square. So sorry, it is not R square. See, the distance between Q1 and Q2 is B, so it will be B square, and distance between Q1 and Q3 is A, so it will be A square. And what will be the direction of the force? The direction of the force will be Z. Q3 will repel Q1, so the direction will be in this direction, right? In this direction. The force will be in this direction. F2 will be in F13 will be in this direction, and this will be the direction of F12. Force on 1 due to 2 will in that direction, and due to this 3 will be in this direction. Now, what you have to find? You have to find the x component. So, see, the x component of F12 is the F12 itself, right? Because the force F12 is along the positive direction of x-axis, but F13 is not along x-axis, right? So you have to find what is the component of F13 along x-axis. So if I want to find component of F13 along x-axis, it will be nothing but F13 cos of this angle. Cos of this angle. What will be that angle? What will be that angle? If this is theta, if this is theta, then this is 90 minus theta, right? Because if you see this is theta, then this is 90 minus theta. this angle is 90 minus theta. If this angle is 90 minus theta, then this is 90 minus theta. So it will be cos of 90 minus theta. And you know, it will be f13, and you know cos 90 minus theta is nothing but cos theta. So what will be the resultant force along x direction? The resultant force along x direction, if I write, the resultant force along x direction will be nothing but f12, because it is along x direction, and the component of f13 along x direction is nothing but f13 cos theta. If you take from f12 and f13, I can take 1 by 4 pi epsilon naught and q1 common. I can take q1 by 4 pi epsilon naught common. Then in f12 it will be q2 by b square, and in f13 it will be q3 by s square, q3 by s square, and it will be cos theta also. So my force along x direction, the x component of force, if I write is fx. Fx means the component of force along x direction. That fx is proportional to q2 by b square plus q3 by a square cos theta. Simply, right? Because this thing will be constant. q1 by 4 pi epsilon is constant, because q1 is the charge of the okay. Okay, so fx is proportional to this thing, and so which option is correct? If you see, this option is correct, right? Option C is correct. q2 by b square, q3 by a square cos theta. Okay, okay. Let's move to the next question. Okay, the question number 8 is, a total charge q is broken into two parts, q1 and q2, and they are placed at a distance r from each other. The maximum force of repulsion between them will occur when, out of these four options, one is correct. You have to tell which option is correct. Okay, okay. Let's see which option is correct. Okay, so the q1 is broken into q1 and q2, and they are placed at a distance r from each other. They are placed at a distance r from each other, and the maximum force of repulsion, we have to find the maximum force of repulsion. First of all, let us find the force of repulsion. Then what will be the force of repulsion? It will be F equal to, what will be F equal to 1 by 4 pi epsilon naught. It will be q1 q2 by r square, right? Now this F will be 1 by 4 pi epsilon naught. Let's say q1, I can write this is q1, and what will be q2? Q2 will be simply q minus q1, right? Q2 will be q minus q1, because the q1 plus q2 is equal to q, so q2 will be q minus q1 divided by r square, or I can write it as 1 by 4 pi epsilon naught q1 q minus q1 square divided by r square. Now, for maximum force, you have to understand, for maximum force, dF by dq1 should be equal to 0. For this is a condition for maximum or minimum. For maximum or minimum, we know that the differentiation of the term f with respect to q1 should be 0, because f is dependent on q1. F is dependent on q1, right? So the df by dq should be equal to 0. Now, what is df with respect to q1? If I differentiate f with respect to q1, then it will be simply, this thing is constant 1 by 4 pi epsilon naught, r square is constant, r square will be as it is. q1 q, differentiation of q1 q with respect to q1 is simply q, and differentiation of q1 square is simply 2q1, and it should be 0. Since this 1 by 4 pi epsilon naught r square are constant, so simply q equal to 2q1, or q1 equal to q by 2. So okay, so if q1 equal to q by 2, then of course q2 equal to q minus q1, it will also be q by 2. Okay, so which option is correct? The correct option is option D. Okay, okay, let's move to the next question. Okay, the question number 9 is, figure shows the electric lines of force emerging from a charged body. If the electric field at A and B are EA and EV respectively, and if the displacement between A and B is R, then you have to choose correct option from this 4 options. Okay, so what we know from the expression of electric field, we know that electric field is proportional to 1 by r square. It is inversely proportional to the square of the distance between the 2 points, right? Then if we go far away from the charge, the electric field will decrease, right? So of course electric field at the point A will be greater than electric field at the point B. So which option is correct? Option A is correct. And by the way, these two options C and D is of course not correct, because dimensionally if you see EA is equals to EB by R, it is not possible, right? Because EA and EB has the same dimension, but R has different dimension. So EA into R will have different dimension than EB. So it is not dimensionally, these two options are neglected. These two options are not correct dimensionally. Okay. Next, let's move to the next question. 10 is an electric dipole with dipole moment 4 into 10 to the power minus 9 coulomb meter is aligned at 30 degree with the direction of uniform electric field of magnitude 5 into 10 to the power 4 Newton per coulomb. The torque acting on the dipole is, out of these 4 options, which one is correct? You have to choose. Okay. So we know if this is the direction of electric field E and this is the direction of the dipole moment, electric dipole P, then you know the electric dipole is directed from negative charge towards positive charge, right? And this dipole will experience a torque due to that E is because this negative charge will experience a force opposite in a direction opposite to the direction of electric field, and this positive charge will experience a force along the direction of electric field, and due to that this dipole will try to rotate and try to align it along the direction of electric field, right? And we know this torque is nothing but the magnitude of that force and the perpendicular distance between them. Okay. So just we know what is that force. We know what is that force. This F equal to nothing but QE. We know that force equal to QE. We just need to find what is the perpendicular distance between them. Okay, we can easily find the perpendicular distance between them. The perpendicular distance between them will be this distance, right? This distance. What will be this distance? If this is L, then, and if it is theta, angle is theta, then it will be nothing but L sin theta, right? It will be L sin theta. So perpendicular distance will be nothing but L sin theta. Then what will be tau? Then tau will be QEL sin theta. Okay, it will be QEL sin theta. Now we can write Q into L separately and E sin theta separately. Now what is Q into L? Q into L is nothing but electric dipole moment P, because this is the charge either of magnitude of either of the charges and the perpendicular and the distance between these two charges, and this is nothing but electric dipole moment. This it will be PE sin theta. Now it is easy, just put the values. The value of P is given. Dipole moment is 4 into 10 to the power minus 9 Newton minus 9 coulomb meter. Electric field is 5 into 10 to the power 4, and the sine of what angle is given? It is 30. So it will be sine 30. So it will be 4 into 5 is 20, and 10 to the power minus 5, and sine 30 is half. So it will be 10 into 10 to the power minus 5, or it will be 10 to the power minus 4 Newton meter, and it will be the option A. So the option A is correct. Okay, that's it for today. Meet you in the next class.